Swayam Prabha. Digital India. Educated India.
Hi, welcome back to Mechanics and Control of Robotic Manipulator. Last lecture where we stopped is basically role of a robotic engineer or design engineer. This is the slide we stopped, and I said that the next lecture we would be talking more about robot mechanics. So we were actually given a small indication so how we can start, you can say, understanding. So before that, let us actually go back to the previous slide. So where we actually stopped, and then we will talk about robot kinematics very detailed. Then we will talk about what are the way to describe the motion. So obviously there are two ways. So then we will talk about the mapping between you can say two different frames, because you know like manipulator is set of bodies, in the sense it is actually like multiple body system. So then we need to have actually like each body at least one frame would be there. But as per the, you can say, robotic manipulator, one link would be having two joints. So that is what we are going to see in upcoming lecture. In the sense you can see like one frame to another frame, that you can say mapping can be done. So this is what we are going to cover in this particular lecture. So let us go back to the slide. So where we stopped. So this is the slide where we stopped. We talk about the workflow, or you can say the basic idea behind the robotic or design engineer. So what would be given? So the design or the task would be given. For example, here I say that the robotic assembly is actually like given. So what are the aspect you will immediately think as an engineer, or probably the original robotic engineer will see, okay, so these are the specification, or you can say these are the user input. So these are the user inputs are given. So what I can actually like choose. So obviously in order to achieve or accomplish this task, we need to think about the real system, right? So that is the next case. You can see the real system is going to come, but the real system from the task, there are several choices. For example, even I said the robotic assembly. So there are several manipulators are available for the robotic assembly. So in that sense, actually like there are several chances. So for example, it comes from 20k to probably 2 crore worth manipulators are there. How will you choose, or what will be the selection of yours, or will you make your own? So if that is the case, what exactly from the task side would be known. So the user would be given some input. Based on that, you would be come up with what you call, already I said the you can see already I said that the desired specification would be obtained. So what that means, the desired specification in the sense, so based on the user input, you would be coming with some kind of technical background on the, you can say, system, or background on the task. But this would give one of the thing, what it is actually like, what would be the body arrangement, whether for example the robot can be fixed on the top, or actually like fixed on the base, or it is actually like put it on the desk. So these all will be actually like selected, and similarly the robot should have these many number of active joints, and all those things will come. So what indirectly it will give, based on that you will come up with one aspect called selection of configuration. For example, in our case the robotic assembly, probably the choice would be either a delta robot or a SCARA robot. So now these two are actually like your choice. Finally you end up with probably a delta or SCARA robot. Then you can see on shelf, in the sense industry catalog or the commercial on shelf, there are several such SCARA or delta, even the brand to brand it get changed. The price also will get changed. So now in that sense, what one supposed to know, you have to see from the real system. So what are the two things will come? So one is selection of mechanical system. The other thing is actually like selection of actuators and sensor. So now these are the aspects which come from the real system, and this is the thing which is come from the what you call a task. So now what we said, so these two things would be bridged by the system, what you call system dynamics. So that is what we have actually like discussed in the last session. So obviously each and every stage would be iterative, but what we said that the gap between the real system and the task would be filled based on the system dynamics. So that is what we actually like discuss. So now the system dynamics will actually like fill the gap. Even the example I gave, that the simple pendulum, how will you actually like design and fabricate? So there are several aspects, right? If you know the system dynamics, even you can easily make it several of these selections or probably fabrications and all, right? So with that, we'll actually like come back to the original content of this particular lecture. So now you got idea, right? What idea? The system dynamics is one of the key. So that system dynamics, how you will actually like relate. So the system dynamics we can simply call mathematical model. So what the mathematical model can do, if you recall the example what we did in the you can say simple pendulum. So you have to actually like select several things, right? So you have to actually like design. I'll just make it. So you have to actually like design. So you have to actually like say, so design aspect is there, then so for design actually like you will be doing some selection, and then actually like this is the mechanical side, then you have to actually like think about the control design. Okay. So even further if you look at it, sometime the parameter would not be known, so you have to actually like estimate, right? So if you take these all the cases, the mathematical model what it does, so it does actually like several of important thing. What? So one is actually like to design, it is actually like going to give, but how will you design? So you will actually like only design based on the, so understand, right? So in the sense, so what the mathematical model will give, so it will give one simple aspect. So you can see like to understand the system behavior, and consequently you can actually like design the mechanical system. So this is one thing. And you all of know that the robotic system is no longer only mechanical device, it's slaved by the controller. So then the controller design also can be done based on the mathematical model, especially if you talk about manipulator. So most of the manipulator come from the model based control, in the sense, so if you have a mathematical model, you can actually like design the controller more appropriately. So further, you know, like the robotic system required some kind of sensing system, navigation systems and all. So if you think about even extended to mobile manipulator or mobile robot, so you can obviously design the navigational system, or you can actually like think about these two systems performance you can adjust with the help of mathematical model. So for example, your controller tuning, or you can say your navigational parameter estimation, these all can be tuned according to the availability of the mathematical model. So then the next step, what you can see, this can be used for example estimating the system parameter. Mainly you can say to predict the system parameter. The prediction is actually like, even it is actually like kind of estimator. Okay, but this estimator can be a different way, what you call, it is actually like a system estimator, but what I am actually like calling the system parameter estimation. So one is actually like parameter estimation, the other one is actually like filtering. Okay, so both the cases we can use if the mathematical model is available. So that is what the whole idea. So to illustrate or mimic or simulate the real system, we can definitely use the mathematical model. In fact, in this course we are going to use that is what as the predominant area. Okay, so if that is the case, you know, now understanding what is mathematical model and why we are using mathematical model. We'll start with the very basic. So what very basic, you know, robotic system is actually like one of the mechanical system. This is involved with you call motion. So obviously the motion can be classified based on the physics. So there are two things, so which is actually like you call statics and dynamics, right? So these all you have seen, and dynamics can be further classified into, so what you call kinematics. Okay, and the other one is actually like you call kinetics, right? So what is kinematics? Kinematics is nothing but the study of motion. So you would be bothering about motion, but without the cause of motion. So who are actually like causes? So that is what the case. In the sense, for example, now you are looking the football game. Imagine that if you are actually tracking only the ball, so what you are seeing, like who is hitting and what way is hitting and how much force they are applying, these all immaterial. You are just seeing that how the ball is moving, right? So in the sense, what one can see, the kinematics is nothing but it is also part of mathematics, but what we are trying, study of motion without considering the forces or efforts that affect the motion. That is what I said, without the causes. So in that sense, what exactly it will give idea for us. So there are two things. So one is actually the geometrical relationship that govern the system. This is what we are going to use as a bigger aspect called robot kinematics. The second thing is this will give a relationship between the control parameter and the behavior of the system in a system, you can say, space, which we simply call state space. In the sense what you have actually like input and you have actually like system motion what you call output. So this relation you will get. So if you have this relation, what you can do, you can actually like get a better idea about the system, and as well as you can think about even better controller. So in the sense what you can see, we are going to talk about the kinematics. What is kinematics? Study of motion without considering the forces or effects that affect the motion. So now we specifically keep this and we will go. When we come to dynamics, we will see what is difference between kinetics and robot dynamics. Okay. Right now we will go with kinematics. So if you talk about kinematics, what we are actually like really bothered. So here the robot manipulator describes the relationship between the motion of the joints and you can say what the resulting motion of the rigid body which form the robot. For example, now you take this is what the body. Okay. So if I rotate this, okay, if I rotate this, what will happen to this set of bodies, how it is arranged or how it move individual body. Although I am actually like giving the motion on the joint, but what we are seeing that the resulting motion of the rigid body, that is what we are focusing. So in that sense you are actually like, I hope now clear what is kinematics and what robot is going to, our robot manipulator what we are going to talk. So if that is the case, we will go even further more. What furthermore? So I am taking one of the industrial robot. Okay. So this industrial robot is actually like something like engraving, or you can say some kind of machining tool which is in-house at the end. Okay. So this is actually like guided through some sequence of motion. In the sense when we are actually like focusing, this is one of the robot manipulator. What would be our interest? Our interest is the tool point. How the tool point actually like move on this metal piece so that the predefined, you can say, engraving or you can say machining can be done. So in the sense what you can see, this end effector motion is important. This end effector motion is actually like px, so the py and pz, and this will be having some set of other variables. For example, this is the orientation the tool supposed to be, and this is the rotary or you can say rotational speed of the, you can say, end mill, all those things. So in the sense what we are actually like bothering about the task. The task would be having set of variable. That set of variable is going to give some kind of space. So the set of variables, okay, so I am making as a small set. So what this give? This give as a space, as a set. So I am calling in a mathematical term as a space. So what that mean? So this space is related to what? The task or the operational entity. So this space I am calling, so operational, so operational space. Okay. So this is what we are always interested. But if you look at this manipulator, what you can see, there is one motor here, one motor here, one motor here, one motor here, another motor here, like that, right? So you have set of motors or set of joints. This is connecting the set of body in such a way that this end effector is actually like following. If you look at the next picture, you may be getting very clear. So for example, you can see this is the base. So this base to this end effector is having set of bodies. So these bodies are actually connected in series and there are several actuators. In this particular robot, you can see there are several actuators, in the sense A1 to A6, there are 6 joint motions which are powered. But these are the motions are actually like making this end effector to follow certain profile. So if that is the case, what you can see, so this A1 to A6 having some set of variable. Okay. So these variables are actually like creating one space. So that space is actually like what? It is actually like how it is configured one body to another body. So we have already seen what is configuration. So obviously this is actually like related to the configuration. So we call this is configuration space. Some people call this is based on the joint, so they call joint space. So now what we have, there are two relations. So one is configuration space. Okay. So the other one is actually like task or operational space. So there are actually like two spaces, but we are interested this, but the robot know only this. So we need to map between these two, either this way or this way. So this is what we are going to call as kinematics. Okay, so that is what we are actually like putting into next picture. You can see one side the configuration space, or we call joint space. Okay, so the other side what you have actually like operational space, or some people call task space. Okay, so now we are actually like mapping in the sense, so you take the set of body and you have actually like know, so what is the angle. For example, I am taking, this is the rotary 2R rotary manipulator. So you can see like this joint angle theta 2 and theta 1 is actually like I fix. What I will get, this end effector point which is Px and Py would be available to me. So in that sense what, so I have configurations variable, so I am trying to find out what would be the operational variable. So this is straightforward look like us, right. So in the sense this is forward kinematics. Okay. So strictly speaking we are talking about geometrical model, but this is what in general we call forward kinematics. The other way around, I say that this is the x1 and y1. Okay. So I have a manipulator. Okay, I am just showing that. So this is the manipulator. This manipulator I have to make sure that this comes here. In the sense what? So I have this. Okay. So in the sense I know the operational space variable, can I find the configurations variable? Okay. In the sense for given task space variable, can I arrange this set of body in such a way that it fulfill that? So this is what you call inverse problem. So we call inverse kinematics. So now we will actually like see a proper pictorial way. So we need to map these two. So for mapping this, what we are seeing, if configurations variable is known and we find what is operational space, this is what you call forward kinematics. And the other way around, you know this and you are finding this, so this is what you call inverse kinematics. So I will write this in a more verbally, in the sense I am writing in a more clear way. So you can see the robot kinematics is having two subsection. One is forward kinematics. What that? It determine the configuration of the end effector, which we mean, so say that the task space variable or task variable, in the sense most of the cases it would be a gripper, some of the cases is like a tool mounted on the end effector of the robot. For given relative configuration of each pair of adjacent link, in the sense the joint variables are given, so what would be the, you can say, robot end effector point. So this is what we call forward kinematics. For that, what one can actually like easily understand in the easily understandable main. So you can see like I give this individual body, so I say this is one body and this body is actually like arranged with another body this form and another body is arranged this form. So like that what I am taking from the, you can say, one end to the free end, I am actually like assembling one body to another body. So then what we can call this forward kinematics in more, you can say, parallel robot community and all, we call it is assembly mode. So you are actually like assembling the set of body in such a way that you will give the final end effector. In the sense you take the free body and put it and assemble so that you will get some kind of mode. So that is what you call assembly mode. I hope you are actually like clear on this. So let us move the next one. What is that? So that is nothing but the inverse kinematics. So what is that? So for given the desired configuration of the end effector, which we mean to say the operational or task space, find variables, in the sense what variable? The joint variable, which are actually like you call configuration variable, which achieve that configuration. Okay. So in the sense what we are trying to see, we are having something, this is the end. Okay. So this is actually like end effector and this is the base. So you have given base and end, you see that how to arrange this. Okay. So in the sense what you have, so you have the working end, okay, and you are trying to arrange your body in such a way that that is making. In the sense what we can actually like call, this is actually like inverse kinematics, where the end effector point is given with respect to the base and you are trying to make sure that what angle it is supposed to be required. That is what you are trying to find out. This is actually like very close to that working nature. So some people call this is working modes. Okay. So this is the two different classification of what you call robot kinematics. I will take one additional slide and end this lecture. So the next lecture we will talk about more about the configurations and all. So but let us actually like take one simple slide. You already know like what is description, But why we need description in manipulator? Because we need to talk about the motion in mathematical quantity. So here the motion is actually like written into two form, the position and orientation. I already mentioned in the last lecture, the position derivative and orientation derivative would be linear velocity and angular velocity, and further derivative would be linear acceleration and angular acceleration. But what we need, so we need to actually like describe or define this is in a mathematical quantity. So that what we can do, we can actually like do further on what you call transformations. So what that one body to another body, we can actually transform the information whatever available to us. So for that, what one supposed to know, you should have one clear definition on the coordinate system. I already said we would be using one of the standard convention called Cartesian coordinate system. So which in the sense mutually perpendicular axis, that is what we have used, right. So I end with this particular picture. So what that mean, you can see like this is the ground, okay. So there is one moving body, I have taken only set of frame. So this is the body frame and this is the ground frame, and now with respect to body I have known one point. Very simple example, you have actually like one big car, okay. The car one, you can say front end, which is what you call the lamp post or probably the symbol or the logo of the car is actually kept. So now you know that with respect to the body, this location, okay. Now I assume that there is a ground. So with respect to this ground, can I actually like define, in the sense, can I define this P point with respect to ground? But what I know the information with respect to body, can I transform? So in that case, what information you require, you can see that the body we call B frame is actually like orient with respect to the ground frame and as well as translated with respect to ground frame. In addition to that, the B frame is actually like having additional point called P. That point P, can I actually like write it with respect to ground? So this is what our interest. So if that is the case, what we can actually like do, we have to first understand how to describe the position and how to actually describe the orientation. Then we can actually say that how to get this relationship between ground frame G to the body frame B. Why we are actually like looking at this? Because we need to have one information what we call P with respect to G or B, one is known, okay. So with that, I am actually like ending this particular lecture. The next lecture would be talking about description of position and orientation. Then we will be talking about how to map, you can say, between two frame, and finally we will end up with something called transformation matrix, okay. So before we are actually going to that, so I am ending this particular lecture. The next lecture we would be straight away talking about description of position and orientation, okay. See you then, thank you, bye.